The injection wells in that diagram get its water from the Orange County Groundwater Replenishment System. I mentioned that this is one of the other sources of water that is used to recharge the Orange County groundwater system. It basically has a capacity of 100 megagallons per day, but it generally operates at 35 megagallon per day of treated wastewater. Again, that wastewater is at about 1,000 part per million salt, as well as other things, of course, which is then treated or purified using reverse osmosis. There's actually 4 treatment steps: pre-purification, which involves removing the coarser materials from it, settling; then microfiltration, which is filtration that gets the particle size down to molecular levels; and the reverse osmosis is this was shown in the photographs on the right are reverse osmosis units. Basically, the water is pressurized into the pipes and travels through the filters that are wrapped around the pipe, and then the water is collected through these filters. And that finally, the last step is ultraviolet light. The water is then put into those groundwater injection wells near the coast to create a seawater barrier. And this is basically an area where the water table is raised up to prevent saltwater encroachment from coming in from the ocean into the shallow groundwater system near the coast. If you take a tour of the Orange County Groundwater Replenishment System, at the end of the treatment system, they invite you to drink water from the treatment system outflow. And it's, something that some people don't feel very good about. Los Angeles, before Orange County, tried to, well, they did do this successfully eventually, but initially when they introduced this wastewater treatment for water supply, it unfortunately got the moniker toilet to tap. That did not sit well with the public at all. So Orange County is very, very careful to not use terminology like that, and I think the groundwater injection barrier is a way to help that. The water is purified to a real high level and then put into these groundwater wells, and then eventually when it becomes part of the supply, it's drawn through regular pumping wells, groundwater wells. The regulation as written is that the water will go into the injection well and will be in the groundwater for 1 year. So the backflow coming off of the seawater barrier is what's collected in groundwater wells behind the barrier, and they want a transport time between the injection well to the pumping well of at least 1 year. West Basin in LA County has an equivalent facility, the Edward C. Little Water Recycling Facility, and they also put their treated water into injection wells to create a seawater barrier. So here's a generalized diagram on how the groundwater barriers work. This is a cross section. You can see the ocean on the left, a land surface on the right. There's a groundwater table, which is the dashed line, stippled dash, which is the point in the ground where you first encounter water, or at least completely saturated water, and you have the groundwater system underneath that. You can see that the treated wastewater is shown as going into the well as a down blue arrow, and this water then is going out the screens at the base of the well. It raises the water table into the dashed line, which creates the pressures that are needed to create the flow both towards the ocean as well as back to the area behind the seawater barrier, which is where groundwater recovery wells are located for water supply. The flow towards the ocean blocks seawater intrusion. The seawater intrusion is indicated by the gray water that's working its way into the deeper aquifer, but the fresh water on top of that then helps to prevent that from happening. The water that is flowing from the well towards the ocean, they estimate about 10% of the fresh water that's treated is lost to the ocean. It's a relatively small sacrifice to keep the seawater out of the aquifer system. Orange County has generally two seawater barriers that they maintain, the Talbert Barrier and the Los Alamitos Barrier. This map is not very legible. It's about the only one I could find that showed the barrier positions in green. You can see where the Los Alamitos Barrier is on the northwest portion of the map, the green line. The other wells that are purple are monitoring wells for the system, and black wells are pumping wells, recovery wells for water supply. The Californians always tell directions by where freeways intersect, so I'll do the same thing. Down in the southeast, you have a large brownish area, which is basically Newport. You can see the back bay. Where the California 55 and the California 73 cross, you get kind of an X, and that X is topped with the 405 freeway, which then runs parallel to the coast and parallel to the coastline. Well, right parallel to the coastline is Pacific Coast Highway, and 405 runs more central to the basin than that, runs up and meets the California 22. You can see the California 22 runs across the top. And where the California 22 comes into the 405 and then straightens out and runs a stretch there, there's the Seal Beach Naval Station. And the Alamitos Barrier provides a gap between the Sunset Beach highland over to the Palo Verdes Peninsula, where the San Gabriel River comes in and crosses that gap there. The Talbert Barrier runs between basically the highlands of Newport Beach over to the Costa Mesa region, Costa Mesa Highland. West Basin in the LA County also maintains two seawater barriers. They have, well, actually three. They have a portion of the Alamitos Barrier. You can see that down in the southeast corner of their county line. Basically taking the Alamitos Barrier from the Orange County line, LA County line near the San Gabriel River. They carry it a little bit further along the 405 into the Palo Verdes region near Long Beach. You can see, or Signal Hill region in Long Beach. Then you can see that there's another gap that is closed off, the Dominguez Gap Barrier, which brings the whole system into Palo Verdes. And again, these are designed to prevent saltwater encroachment into the low-lying areas which have relatively flat water table, in which the seawater, especially with pumping, can be drawn into the fresh groundwater system. And then they also have the West Coast Basin Barrier north of Palo Verdes that runs basically parallel to the Sepulveda Boulevard, which ends up going underneath LAX. And again, that's to prevent saltwater encroachment from Santa Monica Bay going into the West Coast Basin. And that runs basically from Palo Verdes to about Venice Beach area. It doesn't look like it reaches quite up to the Santa Monica Mountains, but it is designed to cover the lowlands along, say, Hermosa Beach on Manhattan Beach and up into Venice Beach. I mentioned the Irvine Desalter project. This does not go into any seawater barrier, but the wells provide a source of water from brackish water that is recovered in the San Diego Creek watershed, which feeds the upper Newport Bay. And those waters are brackish from marine saltwater encroachment. And there's also additional salts that are removed from past agricultural practices, especially nitrate, which is often which is used as a fertilizer. It comes from the ammonia fertilizer. These wells are located along I-5 northwest of Irvine, basically northwest of the Great Park, the former El Toro Marine Base. So I mentioned previously that there's a energy investment in fresh water. And I also mentioned that currently the energy required for the desalination is about the same as the energy required to deliver the water from pumping up the California aqueduct. And that's about 4 kilowatt hour per cubic meter. But that energy, that higher 4 kilowatt per hour 4 kilowatt hour per cubic meter is for full ocean water desalination, and these wastewater treatment facilities are treating water that's much less concentrated, down more along the 1,000 to 1,500 part per million range. And that energy is required to do that level of desalination is less, about 1 kilowatt hour per cubic meter. I mentioned that desalination requires energy. This chart is from a desalination engineering textbook, and it shows different methods of desalination. The different methods are not that important at this point. The one on the left, the multi-stage flash, MSF, is the kind of desalination that most of us think of, distillation, where you use heat to boil water off of the salt, leaving the salt behind, and then recondense the water. And that's a very highly energetic process. It takes 17 kilowatt hours to produce a cubic meter of fresh water using that method. And the other method that's probably deployed more commonly in the United States and is the SWRO, seawater reverse osmosis. Reverse osmosis methods require less energy, 4 kilowatt hour to produce a meter cubed of water, but that energy is mechanical energy, so it's a little bit more expensive to make that form of energy. It has to be converted from a fuel source, usually by driving electric powered pumps, so you have to generate electricity, and there's always some losses involved in doing that. Believe it or not, the multi-stage flash method on the left was 17 kilowatt hour. Even though it requires more energy than the other processes, it's the most used worldwide because all you need is heat, and you can produce heat pretty easily, especially in the Middle East. So multi-stage flash is used for distillation. But if you're going to do reverse osmosis and drive electric engines, you're going to be burning a fuel, and that can produce the CO2. So 4 kilowatt hours is a good number to think of in desalination in the United States, and perhaps the rest of the Western world, where reverse osmosis and engines are used to drive the desalination process. Full seawater desalination is being considered for Orange County. There was a proposal for the Poseidon desalination plant to be built on the grounds of the Huntington Beach AES power plant at the corner of Newland and California Coast Highway, Pacific Coast Highway. This project has been on the books since 2003, and it's been having problems with various levels of permits, California Coastal Commission, Air Quality Board, citizens action groups. They had to get permission from the Huntington Beach city government, and as well as find a customer, the Orange County Water District. The water is fairly expensive, which is part of the concern or the cause of the controversy in the area, as an alternative source, a local source of water, but it is expensive, at least as proposed. That concludes part 6 of my presentation, What's in My Water and Where's It From? Tune in to part 7, where we'll take an overview of the aqueduct systems, 3 major aqueduct systems that supply Southern California.